My name is Jain. I'm a systems engineer in Flipkart. I mainly focus on compute and storage systems. So today I'm going to talk about Flipkart's storage journey, the storage design journey. So in the earlier days, we were using direct attached storage. So you have the compute and storage in the same box. Um, it was working well for us unless you do a large scale data center maintenance. So if it is a small scale failure, it works well for us. But say if you are doing a large scale OS upgrade in the entire DC, you end up uh, replicating the data twice, basically. So the software is capable of handling the failures, but when the software sees the failure, it has to replicate the data and then replicate the data back when the hardware is back online. So this was not working well for us in case of a large-scale upgrades or maintenances. So what we did in 2017, 2018 is moving to a composable infrastructure using JBoards. So these JBoards can be just a bunch of disks or flash or a mix of that. What we want to go in the future is a truly composable infrastructure using network attached storage. So before I go to the design, I wanted to talk about why composability matters for us. So in the earlier design, you have compute and storage attached to the same device. Say, suppose you have a VM running on it, which is using the entire compute, but not not using the full storage. Say it is using only half of the storage. The remaining half of the storage is wasted. You can't utilize it because you don't have the compute. And and another problem is there are a lot of single point of failures in the path to the data. So you have the server components, different server components, the OS and firmware, and the network stack. So all of this can fail, but the storage hasn't failed. The data is available, but the data is available in the media, but it's not available for the user because something has failed in the path. So we have seen in the past, we have seen multiple hardware failures, software failures. They are mostly small scale, but large scale things like if we have to do upgrades or software upgrades or firmware upgrades on the entire fleet, or you have a hardware maintenance on the entire fleet or a network upgrades on the entire fleet. In those cases, it didn't work for us. And storage is sticky. So when I say storage is sticky, is because storage is not available when the maintenance is going on. So users, our cloud users have two options. They can destroy the VM and create a new VM and then migrate the entire data. That works for small maintenances, but for large maintenances, it's a very large operation, large rebalance happening, and it will rewrite the data twice. Another option the clients have is wait until the maintenance is over. But the maintenance can take maybe 1 minute, 30 minutes, 2 hours, or maybe a day. So that is risky because during the maintenance, another replica can fail, so it can cause data loss and all. So this is the design we came up with in 2017. So we have faced all these problems till then, and then we decided, okay, let's not do any more converged storage. So we started using JBoards. So the JBoards can contain, this is a SAS attached JBoard. It can have SAS hard disk or SAS SSDs. And there are 6 or 4 heads connected to the JBoard. And this is connected using SAS cables, as I said. So, and these 6 or 4 servers are distributed across 2 TORs. So what the advantage is that there is no single point of failure in this design. So any component in this path can die. Say a switch can die, a server can die, a cable can die, an IOM also can, the IO module can also die. But in any case, this data is still available in another path. So, but the VM is running on one compute server, one server here. For a moment, it might face some problems. Say, for example, if the machine is dying, it can face some problem for a moment. But we have enabled VM migration so that when the first server fails, it can migrate the VM to the other server. That can be done in case of a router failure also. We can migrate all the VMs running under one router to the other router. The other failures like IOM failures, they are most like active, so user will not even see that failure. Only when the data is, the disk is bad, only when the disk has gone bad, the data is unavailable and then the user has to rebalance. So this is more of a logical design. This is how we have deployed our data center. So what you see is 4 consecutive racks. This racks contains, one rack contains 2 J boards, and each J board is connected to 6 Hertz. So this top J board has servers on the top, and then bottom J board has servers on the bottom. So as and you can see, there are 6 servers connected to the J board highlighted, and then 3 servers are connected to one switch, and then the other 3 servers are connected to the other switch. So, and you can think of Flipkart's data center as replicas of this. And the remaining servers are compute servers, and I have trimmed down a little bit, so there are more, like there can be GPU servers and other kind of device on top also. That's it. I will give it mic back to